Hello students, this is Jisha Mary Jose, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. In this lecture, we will be dealing with some of the topics from CS307 Data Communication, which is a part of the 5th semester BTech in Kerala Technological University. In this presentation, we will be discussing the remaining topics of the second module of data communication, and the textbook that has been referred is Data Communication and Networking by B.A. Forzan, 5th edition. In this lecture, we will discuss about the second kind of transmission media, that is unguided media. Unguided media transports electromagnetic waves without using a physical conductor, and this type of communication is often known as wireless communication, and the signals are normally transmitted or broadcasted through free space, that is air, and these signals will be available to anyone who has a device capable of receiving them. So such kind of media are known as unguided media. In this particular diagram, we have shown the part of the electromagnetic spectrum which ranges from 3 kilohertz to 900 terahertz, and this particular range of electromagnetic spectrum is used for wireless communication. It involves radio waves, microwaves, infrared waves, light waves, etc., which we will see in detail in the upcoming slides. So that is what is unguided media. Unguided signals can travel from the source to the destination using different methods. That is, there are different propagation methods for transmitting signals, and the three types of propagation methods are ground propagation, sky propagation, and line of sight propagation. We will see each of these methods in detail in the upcoming slides. The first kind of propagation model is ground propagation. Here, the radio waves travel through the lowest portion of the atmosphere, almost hugging the earth. And these low frequency signals can travel in all directions from the transmitting antenna, and they usually follow the curvature of the planet. And the distance that is traveled by such kind of signals will depend on the amount of power in the signal. The greater the power, the greater the distance traveled. So such kind of propagation is known as ground propagation. The next kind of propagation model is sky propagation, which can allow higher frequency radio waves to travel. So here what happens is the higher frequency radio waves can radiate upward into the ionosphere, that is the layer of atmosphere where particles are existing as ions, and from this layer they get reflected back to the earth. And this kind of transmission allows for greater distances with lower output power. So such kind of a propagation model is known as sky propagation. The last propagation model is known as LOS, or line of sight propagation. Here, very high frequency signals can be transmitted in straight lines directly from one antenna to another antenna. But the conditions that are required here are the antennas must be directional, facing each other, and they should be either tall enough or close enough together to be not affected by the curvature of Earth. And such kind of propagation can be tricky because radio transmissions cannot be completely focused always. So this kind of model is known as LOS propagation. The section of the electromagnetic spectrum, which is defined as radio waves and microwaves, is divided into various ranges, and these ranges are called bands, and each of these bands are regulated by government authorities, and these bands are rated from very low frequency, that is VLF, to extremely high frequency, that is EHF. And in this particular table we can see the different bands, their ranges, the propagation methods that these ranges use, and some of their applications. So these are the different kinds of frequency bands that are used for performing unguided transmission. So, as we said in the previous slide, for performing wireless transmission, we have the electromagnetic spectrum bands that are being used. And these electromagnetic spectrum bands mainly contain three types of waves, that is radio waves, microwaves, and infrared waves, which are used for wireless transmission. first we will discuss radio waves. They are electromagnetic waves that range in the frequency 3 kilohertz to 1 gigahertz. Now some of the properties are that it is omnidirectional in nature. That is, when an antenna is transmitting radio waves, they are propagated in all directions. This means that the sending and receiving antennas need not be aligned to each other. The sending antenna can send waves that can be received by any receiving antenna. But this has got a problem. That is, the radio waves that are transmitted by one antenna are susceptible to interference by another antenna, which may send signals using the same frequency or band. And these radio waves are usually propagating in the sky mode propagation, and that is why it can travel long distances. And also because of that, it can be used for long distance broadcasting, that is AM radio. And these radio waves usually are of low and medium frequencies, and they can penetrate walls. This is also an advantage and a disadvantage. It is an advantage because the AM radio can receive signals inside a building, but it is a disadvantage because we cannot isolate a communication to just inside or outside a building. Then the radio wave band is usually narrow in nature, that is around 1 gigahertz, and because of this it is less compared to microwave band. And when this band is divided into sub bands, the sub bands are also narrow in size, which is leading to a low data rate for digital communication. And almost the entire band is regulated by authorities. So this is known as radio waves. As you can see in this diagram, radio waves are transmitted using omnidirectional antennas, and the property of this antenna is that it can send out signals in all directions. And based on the wavelength, strength and the purpose of transmission, we can have several types of omnidirectional antennas. One particular diagram is shown over here. Now what are the applications? Because of the omnidirectional characteristics of radio waves, it is mainly used for multicasting, which is there will be a sender and many receivers. So we can have AM and FM radio, television, maritime radio, cordless phones, paging, etc. The next kind of waves are microwaves. They are electromagnetic waves whose frequencies range between 1 to 300 gigahertz. And some of the properties of microwaves are that they are unidirectional in nature. That is, when an antenna transmits microwaves, they can be narrowly focused. This means that the sending and receiving antennas need to be aligned to each other. And this has got an advantage. What is the advantage? A pair of antennas can be aligned without interfering with another pair of aligned antennas. And some of the other properties of microwave propagation are that it is line of sight in nature. That is, since the towers with the mounted antennas need to be in direct sight of each other, the towers that are far apart need to be very tall. And the curvature of the earth as well as other blocking obstacles do not allow two short towers to communicate by using microwaves. And due to this reason, repeaters are often required for long distance communication using microwaves. And these waves are very high frequency in nature and they cannot penetrate walls. And this is a disadvantage because if the receivers are inside buildings, the signals cannot be received. Then the microwave band is relatively wider compared to radio waves, that is almost 299 gigahertz, and that is why we can have wider subbands and a higher data rate is possible. And the use of certain portions of this band requires permissions from authorities, otherwise it can be used freely. So this is the second kind of waves, that is microwaves. In comparison with radio waves, which used omnidirectional antennas, in microwaves we have unidirectional antennas that can send out signals in one particular direction. And there are two kinds of antennas for microwave communication, as you can see in the diagram, the parabolic dish antenna and the horn antenna. We'll see each of them in detail. The parabolic dish antenna is based on the geometry of a parabola. That is, every line parallel to the line of symmetry or line of sight will reflect off the curve at angles such that all the lines will intersect in a common point called the focus. You can see in the diagram. And the parabolic dish works as a funnel, catching a wide range of waves and directing them to a common point. In this way, more of the signal is recovered than would be possible with a single point receiver. Then, the outgoing transmissions are broadcast through a horn that is aimed at the dish, and the microwaves will hit the dish and are deflected outward in a reversal of the received path. This is how the dish antenna works. Now the second one is the horn antenna. It looks like a gigantic scoop. The outgoing transmissions are broadcast up through a stem which resembles a handle and deflected outward in a series of narrow parallel beams by the curved head. Whereas received transmissions are collected by the scooped shape of the horn in a manner similar to the parabolic dish and are deflected down into the stem. And what are the applications of microwave? Because of its unidirectional properties, it is very useful when we want unicast, that is one-to-one communication between the sender and receiver. And that is why it is used in cellular phones, satellite networks, wireless LANs, etc. Microwave signals are of two types, terrestrial microwave and satellite microwave. The first kind of microwave is terrestrial microwave. From the word itself we can understand it is related to earth, and it uses directional parabolic antennas to send and receive signals in the lower gigahertz range that is assigned to microwaves. And these signals are highly focused in nature and they follow line of sight propagation model. And we need to use relay towers and repeaters to extend the range of communication of such kind of signals. And these signals are mainly used in areas where cabling is difficult, that is in areas like hilly regions and rivers. The next kind of microwaves is satellite microwave. So again, from the word itself we can understand it is related to space. That is, the waves can be transmitted from the earth at almost 6 gigahertz range to a satellite that is positioned in space, and the transponders that are present inside the satellite can amplify and strengthen the signals and can send them back to the earth at a frequency range of 4 gigahertz. So such kind of a transmission is known as satellite microwave transmission. And what are the disadvantages of this particular method? That is, it can involve high cost for setting up of satellites, and also some kind of security measures need to be set up to prevent tampering of information that is traveling from earth to space and from space to earth. So this is known as satellite microwave. So these are the two kinds of microwave transmissions, terrestrial and satellite, depending on whether I am using the microwaves for communication in earth or from space. The last waves that we need to discuss is infrared waves. They have frequencies ranging from 300 gigahertz to 400 terahertz, and their wavelength is correspondingly 1 millimeter to 700 nanometer. And the main application of such kind of waves is for very short range communication. And these infrared waves, which have very high frequencies, cannot penetrate walls. And this advantageous characteristic prevents interference between one system and another. That is, a short range communication system in one room cannot be affected by another system in the next room. And when we use our infrared remote controls, we do not interfere with the use of remotes of our neighbors. So this is the main application of infrared waves. However, this same characteristic makes infrared signals useless for long range communication. And in addition, we cannot use infrared waves outside a building because the sun's rays may contain infrared waves that can interfere with the communication. And the main application of infrared waves are for communication between keyboards, mouse, PCs and printers. So, if we talk about wireless channels, we can see that it is subject to a lot of errors compared to wired media. Interference is one of the main cause, which can be circumvented with a high SNR, that is signal to noise ratio value. The higher the SNR value, the less capacity is available for transmission due to the broadcast nature of the channel. And such kind of wireless channels are also subject to fading of signals. Finally, we can perform a comparison of wired and wireless transmission media using various factors. Some of the factors are listed over here. First one is bandwidth. The wired transmission media's bandwidth will depend on the media that I am using and it can be large. Whereas for wireless, it is generally narrow in nature and it will be regulated by some authorities. Then, next factor is signal reception. It is reliable due to the dedicated links that are provided in wired media, whereas signal reception is unreliable in wireless because the signals can be either blocked, reflected, or maybe interfered. Then, security is very high in wired networks because it is difficult to tap into wired networks, whereas in wireless, everyone within the range can intercept the messages. Then, interference is very little in wired, whereas it is significant in wireless networks because all of us are sharing the same medium, air. Then mobility is not possible for wired, but it's possible for wireless. And cost will depend on the type of media that I'm using. And expansion will again be possible in wired because I can add more wires, but in wireless it will depend on various factors like whether I'm using repeaters, amplifiers, etc. So this is how we can compare wired and wireless media. With this, we come to the end of this particular presentation. So in the second module, we discussed transmission media which involved wire transmission media like twisted pair cable, coaxial cable and optical fiber cables. And we also discussed wireless transmission media which basically involved radio waves, microwaves and infrared waves. Thank you.